Hey guys, Mr. Backerberg here. In this video, we're going to look at the definition of a function and also function notation. So the first thing I'm going to do is throw the actual math definition of a function and domain and range at you, and then we're going to look at them and hopefully make them a little bit simpler to think about. So a function from set D to set R is a rule that's going to assign each element from set D a unique element in set R. All of those values from set D that we're plugging in, we're going to call the input values, and we consider those to be the domain of our function. And then all of those elements from set R, those are all of our output values, and we call that the range of our function. Now, one way you can think about a function is as a machine, and you're taking and you're plugging stuff into your machine. And your machine, it has very special rules that it has to follow with whatever it is that you're plugging in to give you some sort of output value. Now the things we're plugging in, that's the domain for our function, and the things that get spit out, the output values, that's the range of our function. And typically when we're plugging things in, we consider those to be our x values, and the things that are coming out of our function, those would be our y values. But we have a special way of showing that we're dealing with a function. So instead of using y values, we're actually going to call those values f of x values, where f is the name of our function, and this is a function of whatever x values it was that we were plugging in. Another thing we can do to show what a function looks like is something called function mapping. Now in this function map, what we've got happening is on the left hand side we have our domain, and that's made up of some x values, and on the right hand side we have our range, and that's made up of some y values. So what we can see here is that each x value is matched up with a specific y value. Now if we look, x3 and x4 are each matched up with the same y value, but that's okay. The only thing that would not be okay is if we had one specific x value being mapped out to two different y values. So this mapping does represent a function. But if we looked at a similar mapping, now I've changed things a little bit. If we look at this x2 value, x2 is being mapped to y2, but x2 is also being mapped to y3. So we have one x value going to two different y values, which is bad. So this mapping does not represent a function. So here in this first example, we want to figure out, does the equation y equals x squared define y as a function of x? So one of the big things we were looking at is with a function, when we plug in an x value, we should get back a very specific y value. Well here, like if we plugged in 2, we know that we're going to get 4 as our answer, because if we plug 2 in for x, 2 squared is 4. Or if we plugged 3 in for our x, we would get 9 as our answer. Or if we plugged in 7 for our x, we would get 49 as our answer. Each time we plug in an x value, we know what y value we're going to get back because this rule tells us what to do. So yes, this one does represent y as a function of x, so we can write it as a function. And remember, in order to write something as a function, what we're going to do is we're going to get rid of that y, and we're going to replace it with our function notation, which says f of x equals x squared. Now when we're writing things in function notation, this doesn't have to be f. Okay, this could be really any letter. This is just the name of our function, so we would call this function f because we named it f of x. Now we can also look at functions graphically. So there are 3 graphs drawn out on some grids for us. One of these graphs does not represent a function, and we want to figure out which one and how we can test for it. The big thing we said that we were looking for was to make sure that each x value was matched up with just one specific y value. So I'm actually looking at this graph on the far right hand side, and I want to look at the x value of 0. That's right along our y-axis here. And if we look at that x value of 0, there's actually 3 points on our graph where they have an x value of 0. And that's going to be a bad thing, because this is saying that we've got the same x value being matched up with multiple different y values. So this one is not a function. And the test that we can run in order to show if something is a function or not a function is the vertical line test. And what the vertical line test says is, if you draw in a vertical line along the graph of a function, if that line hits your graph in more than one place, then your graph does not represent a function. So like if we were to look at these other 2 pictures, if we draw in some vertical lines, no matter what vertical line I draw in, it's always hitting my graph at just 1 point. So these ones all pass the vertical line test, whereas that graph on the right hand side fails the vertical line test because it's hitting this graph at more than 1 point. That's going to be it for this video. Thanks for watching.